If you take some magnesium, a little magnesium ribbon strip, and put it inside this lidded ceramic dish called a crucible and heat it up to a really high temperature and wait long enough, it will react with oxygen that's in the air in the crucible and it'll form a compound between magnesium and oxygen. By taking weights at various times, you can calculate what the ratio of magnesium mass to oxygen mass in this compound is going to be. That's what I want to do here, but I also want to go one step further and use that data to find out what the formula is for the compound that's formed. I did this 4 times. This is the data for my first trial. The crucible and the cover together weigh 52.20 grams empty. When I add the magnesium, the mass goes up to 52.47. So the difference between those two lines of measurement is going to be the mass of just the magnesium that reacted in the compound. I began to heat it. After 15 minutes of heating, I had 52.62 grams. After 18 minutes of heating, I had 52.62 grams again, which looks stable. When I took the lid off and checked inside, it looked like maybe there was some unreacted magnesium, so I crushed it and kind of stirred it around a little bit, and then I heated it for 3 more minutes, and the mass went up to 52.64 grams. Now, it doesn't show on my picture, unfortunately, but I heated it for 3 more minutes, and after 24 minutes, the weight was still 52.64 grams. So I felt that that was stable, and I heated it again for 3 more minutes, and it was, in fact, stable. So the final weight was 52.64 grams. So the difference between that, 52.64 grams, the final weight, and the weight when there was only magnesium in the compound, or in the dish, I should say, that's the weight of the oxygen that was in the compound. So again, the difference in the first 2 lines is the mass of magnesium, and when you do the arithmetic, you find out that that's 0.27 grams of magnesium. The difference between the final weight and the weight with the magnesium is the mass of the oxygen that was in the compound, and when I do that arithmetic, I find out that's 0.17 grams of oxygen. But remember, I did this 4 times, and so here's the data for all 4 trials. When I take the magnesium mass in the second column and divide by the oxygen mass in the third column for all my trials, I get 1.6, 1.6, 1.5, and 1.6. That's pretty close agreement. I only have 2 significant figures here, and at the last decimal place level, there is agreement. When I average these, I get 1.57, which is the definite proportion that the law of definite proportions predicts that I should find. Now, this is only 4 trials, but if I did this many, many times, I should close in on an average that's pretty close to what I already have if I'm careful and don't make any mistakes in my procedure. But what I'm more interested in now is finding out what is the formula for the magnesium-oxygen compound. And the numbers in a formula like H2O are representative of how many particles are there, not the mass. But the number of particles is going to be related to the number of moles. And so what I want to do is find out how many moles of magnesium and how many moles of oxygen I have, and then find that ratio. I can do that with a proportion. If I look on the periodic table, I know that 1 mole of magnesium weighs 24.305 grams. So that is a definite proportion that I can carry over to the other side of an equation and take my mass of magnesium, 0.027 grams, and know that if I divide it by the number of moles, I will have the same ratio. So this becomes a simple proportion that everybody knows how to solve, and you cross multiply and divide 0.27 by 1, and then dividing that by 24.305 gives you the value of X, which turns out to be 0.011 moles of magnesium. I'll do the same thing for the oxygen in that trial. This is the first trial again. Oxygen weighs 15.999 grams for every 1 mole. So if I have 0.17 grams, dividing by the number of moles that are in 0.17 grams should give me the same ratio. So X is 0.011 moles of oxygen when I do my solution. Now if I look at the ratio of magnesium moles to oxygen moles, both numbers were the same within the precision that I have, and so my mole ratio is 1, or 1 to 1. So that means 1 mole of magnesium reacted with 1 mole of oxygen, So the formula for my compound is MgO. But I did 4 trials, so to be consistent, I should find this ratio for all 4 of my trials. And here's what I have. And it's interesting to note that I don't have the same number of moles every time, just like I didn't have the same number of mass every time, but the ratio is pretty consistent. 1.0, 1.1, 0.96, 1.0. It's all pretty close to 1. And when I average it, I get, in fact, 1.0. So with my 4 trials, it's pretty reasonable to believe that the formula for magnesium and oxygen in a compound is just MgO. I wouldn't publish that in a scientific paper unless I had many, many more confirming trials, but that's what it looks like so far. So that's how you can find the simplest formula, or it's called the empirical formula sometimes, for a compound using data about its mass.